All right, today we are speaking on quality control in food, the microbiology aspect of food assurance and safety. I'm your regular tutor, Bamjele Odumosu. And we will go through the lecture and have more teachings. Food analysis in both natural and processed form relies on standardized lab techniques to review a variety of qualities. These qualities shed light on things like food makeup, structure, and chemical and physical properties, as well as the presence of plant-based chemicals and how it appeals to our senses. This knowledge is essential for understanding what makes food thick, for producing consistent, safe, delicious food, and for empowering consumers to make informed dietary decisions. So by analyzing food, both fresh and processed, using standardized lab methods, we gain valuable insight into their diverse characteristics. This knowledge encompassing everything from composition and structure to chemicals and sensory properties is a key to understanding food processing, consistent, safe, and enjoyable food options, and helping consumers make informed dietary choices, like I said earlier. Food quality control encompasses a set of rigorous standards employed to ensure that food products consistently meet consumers' expectations and safety requirements. This necessitates the meticulous monitoring of various parameters across different dimensions. For instance, sensory attributes. These relate to the organoleptic properties perceived by consumers, including flavor, color, aroma, taste, and texture. Maintaining consistency in this aspect is crucial for ensuring consumer acceptance and satisfaction. Also, quantitative properties. This includes measuring characteristics like the percentage of key nutrients such as sugar, protein, and fiber. Rigorous analysis ensure that the food product meets nutritional labeling claims and dietary guidelines. And other hidden attributes, which encompass chemical and biochemical parameters not directly perceivable by consumers. These are attributes which are not labeled. These include peroxide levels, free fatty acid, and enzyme activities. So monitoring these factors help prevent food spoilage, ensure food safety, and maintain long shelf life, and also protect the consumer in consuming these products. So by diligently monitoring and controlling these diverse parameters, food producers can deliver safe, nutritious, and consistently enjoyable food products that meet consumer expectations and contribute to public health. So achieving optimal food quality requires a multifaceted approach, integrating aspects of food science, technology, engineering, and consumer behavior. So food safety is important because it helps to regulate presence of harmful bacteria, pathogenic organisms which can lead to infection. Example, we have listeria, salmonella, also toxic chemicals which include pesticides, herbicides that are used in the raw materials perhaps from the farm, and these are brought to the laboratory where these foods are produced, and other extraneous matters such as metal, insect matters, and so on. Therefore, food manufacturer ensures that all these are being taken care of to preventive measures to eliminate these harmful substances from food are properly taken care of. And government laboratory use analytical techniques to analyze food and detect such toxic substances and also ensure that the food is safe for consumer use. So we have instrumental techniques that are meant for assessing food qualities. These techniques are used for evaluating the organoleptic qualities of food as claimed, and we have different types of these instruments. They are basically under the three category of chromatography, spectrophotometer, and electric nose. The purpose of this instrument is to allow the sensory evaluation of these food substances and identification of the aroma active compound, which is possible on the basis of simultaneous use of detectors, especially the gas chromatography and other compound detectors in food components. So for spectrometry, this technique offers a powerful and versatile approach for quantifying the concentration of solutes in solution by measuring their light absorption properties. This principle underpins various analytical methods, including the near-infrared spectroscopy, which has emerged as a valuable tool in the food industry. We call it NIR. NIR spectroscopy leverages the absorption characteristics of specific food components in the near-infrared region around 780 to 2500 nm of the electromagnetic spectrum. So by analyzing the pattern of the light absorption, this technique can provide rapid and non-destructive measurement of key quality parameters such as the moisture, fats, protein, and sugar content. So the absorbing ability of this food substance gives it an interpretation, and this capability also makes the spectroscopy highly attractive for food quality control agents and also grading application within the food processing and agricultural products in the agricultural sector. There are several advantages which the use of NIR spectroscopy in food analysis is rapidly allowing for real-time measurements and minimizing production delays and optimizing process efficiency. Moreover, the non-destructive nature of these techniques eliminate the need for sample preparation, preserving product integrity and reducing waste. Additionally, it offers multi-component analysis simultaneously. That is, can analyze multi-components of a food substance, not just one content. And various constituents can be measured in a single assay, further streamlining analytical workflows, time consuming. So it doesn't consume time. You don't have to analyze one one constituent after they repeat again. You can analyze simultaneously various constituents. So the NIR spectroscopy holds significant promise for advancing food quality assessment and control. It's rapid, is non-destructive, and has a multi-component analysis capability that provides valuable insight into food composition and enable improved product consistency and enhanced consumer satisfaction. So we have the Raman spectroscopy, which provides also non-destructive and label-free method for analyzing the molecular fingerprint of food samples. This unique fingerprinting allows for the identification and characterization of a wide range of components, and this includes spoilage of food substances and contaminants. There are some microorganisms that can cause spoilage of food, and they also have the pesticide residues and other harmful substances which can easily be detected by this spectroscopy. It also allows for identification of adulteration. Certain ingredients are low-grade ingredients or unacceptable ingredients that appears to be alternative for some production. They are like adulteration. So it allows such intentional addition of unauthorized or cheaper ingredients for detection, especially in some products that can be consumed, such as milk, and all that. Then specific ingredient contents, the presence and quantity of desired components such as the specific spice that's supposed to be in a product can be accurately determined, or specific ingredient could be vitamins in sense like that, but it's not used for determining vitamins. This capability makes Raman spectroscopy a valuable tool for ensuring food authenticity and safety. And by rapidly and accurately verifying the composition of food, it can also help to prevent fraudulent production. It prevents food fraud and protect the consumer from adulterated or unsafe products. It also enhances quality control measures through the food chain supply and allows food traceability, improvement, and transparency. It has several advantages over traditional analytical methods, and this includes rapid analysis because it can be obtained in minutes, and it's real-time inspection and you can decide on what to do with it immediately. It doesn't take time, and also the sample preparation is minimal. It doesn't have a lot of pretreatment. Doesn't even need a pretreatment, and analysis time is so short, and it's highly specific. That means it is specific. It provides precise identification and differentiation of components, and it's non destructive. Non destructive means it does not alter the sample. It can allow the sample for further analysis or even direct consumption after analysis. There are certain analytical methods that can alter the food, but it doesn't alter the food. So we have chromatography. Chromatography is a technique that is used to separate components of a mixture. It works based on the principle of different affinities and migration of various components in phases. We have the mobile phase and we have the stationary phases. So chromatography is also used in detecting harmful substances such as pesticide, mycotoxin content in food, environmental pollutants in food and beverages. So it is used for identifying and measurement of essential nutrients that are present in food such as sugar, vitamins, fatty acid, and other vital components in food to ensure nutritional information is accurate as claimed and support dietary needs of the consumers. Certain consumers, they require certain dietary needs. And when they see the label of the product, they believe that this is the component that's present. This is the content of the food product. So they believe it. And if the product does not provide as advertised, then the consumer is being robbed like a fraud. So this helps to protect the consumer dietary needs and authenticate the uh, product claim. It helps to assess freshness and quality and detect spoilage also. And there are some spoilage markers which include volatile amines and organic acids. It helps to identify the potential hazardous food products. And also in authenticity and verification, it differentiates between authentic and adulterated products. For instance, in detecting um, olive oil blended with cheaper oil. Olive oil is more quality than other cheaper oil. So certain products that are supposed to contain olive oil as ingredients, the taste is different when you use cheaper oil. So it helps to maintain the integrity of the product and prevent fraud. Also, it also helps in flavor profiling, unraveling the intricate blend of volatile compounds that are responsible for taste and aroma, and empower scientists to develop new products, improving existing ones and ensure consistency. So we have types of chromatography. We have the gas chromatography, which is called GC. It's an essential analytical technique for assessing freshness and shelf life of food product, like we said. It achieved it by separating and identifying the volatile compound present in the food, such as pesticide, aroma components, and fatty acid. So the presence and level of this compound can be indicative of the freshness and potential spoilage of the food. That is, the presence and the level of this compound indicates, oh, it is fresh, or there is a potential spoilage component, and you can determine the shelf life of the food to be analyzed. So the GC helps, and it is sensitive and it's also specific. It's highly sensitive and specific in its technique, which can detect trace amount of volatile compound, even if it's trace amount. If the product is not supposed to have any trace amount of volatile compound, it can detect it and this is removed. It also makes it ideal for identifying subtle change in food composition that might be indicative of spoilage. When some ingredients have a change in their constituents, it's an early indication of potential spoilage, so that when the food is being kept on the shelf life is being protected. Otherwise, a food that's supposed to expire in the year 2027 can expire, or the taste can go flat by the year 2024, based on the fact that the ingredients are already spoiled. So it can also be used to analyze wide range of these volatile compounds and assessing their quality and their safety in various food substances. It is also non-destructive. It doesn't alter the food, and the food can be consumed immediately being assessed. So we also have the HPLC, which is called the high performance liquid chromatography, which which also is a very powerful technique for identification of non-volatile compound encompassing such as vitamins, minerals, pigments, and sugars. Its versatility renders it an invaluable tool in the field of nutritional analysis and food safety. Then we have the mass spectrometry. Mass spectrometry is a powerful analytical technique that can be coupled with chromatographic method like GC or HPLC. It can be mounted, just like you see here, it can be mounted on a GC or HPLC to provide detailed characterization of food components. Now, this method combines two key advantages for the food analysis. One is that it helps to determine the molecular weight and structure. It can directly measure the molecular weight of a compound, and in many cases it can also provide information about the structure. So it is invaluable for identifying unknown contaminants or adulteration in food, as well as for verifying the authenticity of food products. For example, the MS can be used to distinguish between natural honey and the honey that have been adulterated with sugar syrups or sugar cane. Some people can sell a fake honey and it's just with too much sugar content, whereas a pure honey does not have any sugar. So it can differentiate this. And it has an in-depth, this is the second advantage now, it has an in-depth characterization. In addition to its molecular weight and structure, it can provide in-depth information about the composition of a food sample at the molecular level. Now, this includes the identification and quantification of individual components such as fatty acid component, amino acids, and vitamins. And this can be used to assess the nutritional quality of food and to track the origin of food products, and to also develop new and improved food products. So we also have the thin layer chromatography. Thin layer chromatography is widely used in food science analysis due to its simplicity, rapidity, and effectiveness in qualitatively separating and identifying the diverse components present in food extracts. It's explore various types of methods and application. In food application, TLC can be used in analysis of food and authentication of adulteration and detection like the previous ones, and identifying presence or absence of specific markers to verify the authenticity of food product and detect potential adulteration. Then it can also be used for nutritional analysis in relative abundance of specific nutrients such as vitamins, antioxidants, and like pigment and so on. Then for food safety screening for presence of contaminants or harmful components such as mycotoxin and pesticides. So the advantage of TLC compared to other analytical methods is that TLC offer simplicity and rapidity, and it gives a visual separation of the identification of the product that has been separated on the TLC plate. When I say comparatively, I'm talking about other analytical methods that are traditional based. And it's cost effective. It requires minimal sample volume. It doesn't take a lot of samples, and the reagents are not costly, making it an effective, cost-effective analytical tool for food analysis. So the texture analysis is another way of the tool. This is different from chromatography, it's different from spectroscopy. It's texture analysis. Texture analysis measures the textural quality of the food, the property of a food based on its hardness, smoothness, crispness, and when you chew them in the mouth, chewiness, gumness, how they feel in your mouth, how this is being reflected. So the data is crucial for optimizing product development, ensuring the consistency, quality, and predicting consumer acceptance or rejection based on food production. So texture analysis are specific products that can be applied for. Then we have the electric nose. The electric nose consists of electrochemical sensors that help to mimic the human sense of smell and taste. Rather than smelling certain food product directly, which can sometimes have olfactory effect, or some people can be very sensitive or allergic to some smell and taste, this device helps to carry out this analysis by providing the sensory information and transmitting it to the computer for interpretation. The system is capable of identification of simple and complex odor. It is used in detecting different aromatic compounds. And the way it works is being connected to the system. This is the sample that is being investigated, and you have array of colors. There are so many patterns, but this is just a diagrammatic pattern of how it works. These are array of signals that once this sample is passed through, is sent to the computer and it is being interpreted. So the computer has a pattern classifier or pattern recognition that can give information or depict the content that is present. If it's the taste or the smell, it interprets it and inform the user that this food product contain a volatile compound such as this and such as that. So the Electric nose is essential, is useful, and it helps in place of direct taste or direct um, smelling of certain food products. And there are some food products that the even individual, when you smell, some people may have a bad sense of smell, you may not be able to recognize, or even bad sense of taste, but this gives an accurate sense of smell and taste for product. This is a practice question on what we have talked about. A bakery is experiencing problem with the texture of their bread. The loaves are coming out dense and crumbly, lacking the characteristic light and airy quality. So they suspected an issue with the flour, but also want to rule out other potential factors. So tell us, which instrument technique could be used to analyze the bread and identify the source of the problem, and briefly explain the principle behind each technique and how it might be helpful in this specific case. The answer to this is found at the end of this class. So before we round up on this class, let's look at quality parameters. So in order to ensure the right quality of food products, there are parameters that are evaluated. We have the phytochemical parameters, we have the physicochemical or rheological parameters, we have the packaging parameters. So the phytochemical parameters are those that are evaluated in vegetables, fruits, and so on. And this includes the antioxidant activity, ascorbic, lycopene, beta-carotene, and so on. While the physicochemical and the rheological parameters include those chemical components and the textural part of the food substance. The packaging materials include what will be used in packaging these substances. The packaging materials, how effective are they? Some, can they react with the food, or can they be of, the packaging material is supposed to be non-reactive and supposed to protect the food from being from far from, for instance, from moisture or from direct sunlight and so on. So these are tables that shows quality parameters and the instrument or chemical that are used, and example of the products. So we have the physical, chemical, and rheological parameters here. So we have the admixture, we have the turbidity temperature, and so on and so forth. Also here we have quality parameters and the packaging materials that are used, and the chemicals and the products corresponding for it. You can go through them and have a knowledge of what we're talking about. So, benefit of food analysis. Why do we carry out food analysis? It allows for effective removal of toxic substances from food products. These toxic substances can lead to allergic reaction, can lead to organ failure, it can lead to cancer, it can lead to so many unforeseen circumstances. So it is imperative that these substances are removed from products, and also help to increase the shelf life of the food during storage and deteriorate the quality of the food. And food are also safe from spoilage, and microorganisms are removed, and the quality of the foods are also improved, especially for people that have certain conditions such as diabetics. High sugar content are removed. When they see the label, they know they are not consuming food that can um, you know result to other complication in their health. And certain people cannot consume some common food elements, then it adds extra nutrients. such as vitamin to diet, which are responsible for food development. So that is all for that. The answers to the questions is here. You can see after the slide. The answers are here. Yeah, these are the answers. You can go through. Thank you.